You're welcome to my Calculate Math YouTube channel where I'm devoted in building students zero tolerance for the fear of mathematics.
Since you all know that you are going to be seeing a lot of integration problems in your exam and evaluating them sometimes can take a whole lot of time. In this video, I'm going to be showing you with different examples on how you can solve definite integral using your calculator. I'm going to be using Casio FX 991EX Plus.
If you would like to purchase a good calculator at an affordable price, you can just send a message to the WhatsApp number. You can also see the price of each calculator displayed, and the discount is actually for the first 20 people to message the WhatsApp number. You see, you don't just learn by watching. You need to get your pen and paper and work along with me. Now, before I go ahead, help us to share this video to your class group chats. There are a lot of students out there that this is exactly what they just need for them to pass this course. Also, don't forget to subscribe to this channel if you haven't done that. So, without further ado, let's head over to our video for today. In this question, we asked to evaluate the integral from 1 to 4 of x raised to the power 3 over 2 all divided by 8 minus 4 over x dx. Now, for us to do this on a calculator, the very first thing I want to do anytime you are doing performing any evaluation is for us to reset the memory of the calculator. And how can we do that? We press our shift button, then press the 9 button. Now it's asking us that do we want to clear all the setup, the memory, or all? We want to clear all. So we press 3, then we press the equals to sign, then we press the AC key. Now that we are done with that, let's now compute our integral. Now don't forget that this is a definite integral. Okay, so you can see the button directly below the alphabet key. So let's press that key there. So you can see that we have the definite integral set up here. Now here it is asking us to evaluate the integrand, okay, of the integral. Okay, now the integrand here is our x raised to power 3 over 2 all divided by 8 minus 4 over x. Now for us to do that, I always advise students to always open and close a bracket anytime you are imputing the integrand. So let's open a bracket and close a bracket. So I can now navigate directly in the middle of the box here. Now if I do that, so here you can see that my cursor is already inside the box. Okay, so now I can now input my integrand. Here we have x raised to power 3 over 2 all divided by 8. Now for me to do that, I will make sure I have my fraction. Okay, then next I have my variable x. Because we are integrating with respect to x, just know that the default variable anytime you are using your calculator is always x. Okay, so for me to activate the alphabet x button, alright, so here you can see the alphabet button here. So if I press the alphabet button, what do you notice? That means I've already activated the alphabet key. Here you can see that there is a capital letter A directly above this your integral sign. You can see that at this upper bar of the screen you can see A, D and your math. So this A signifies that you've already activated the alphabet button. So once I've activated the alphabet button, if I press any alphabet key here, you will see that the alphabet will come out. So for example, now if I press this key here, you can see that I have my alphabet A, but I'm not interested in alphabet A. I need alphabet X. Again, I'll delete it, then press my alphabet button again, then press my alphabet X. Now once you press your alphabet X, I can no longer see the alphabet directly above this place again, directly above the screen of the calculator again. That means that anytime I want to press my alphabet X, or anytime I want to have my alphabet button, I need to press the alphabet key again. Alright, so once I'm done with that, then I can now press the raised to power key here. So I have raised to power 3 over 2. So we have 3. So for me to have a fraction, that means I need to press the fraction key here. Then after that, I can now input that 3 over 2 here. So I have 3, then come down here, then put 2. Okay, so once I'm done with that, I can now navigate to this box here. So let's navigate to that box. Oh, we are there. So we have 8 here. So we have x raised to power 3 over 2, then all divided by 8. Then here we have minus 4 over x, 4 over x. Okay, So here I can now navigate towards this place, then press minus. Here I have a fraction again. I press the fraction key and I have 4 over alphabet. I press the alphabet button, then I press X. So I have my 4 over X. Now after that, I need to put in my lower limit and my upper limit. So if I press the arrow down, I will just want to find a way in which I can navigate to this box. So once I press the arrow down button, it will navigate to that box. Then I have this to be 1. Then for the upper limit, I press the upper navigation key, and that means I have this to be 4. And once I'm done with that, then I can now press my equals to sign. Boom, I have my result, which is minus 3.995 blah blah blah. Now if you should check the option here, you will see that you cannot see anything like minus 3.955 because the calculator is actually using a special numerical kind of integration for integrating this kind of function. So it may not give you the approximate or the close form of this integral, but you can just quickly use a calculator to test for all these values to see which one correspond to your integral. Now the very first thing you might want to do is to make sure that you write out your answer somewhere, because we are still going to make use of the calculator to see which one corresponds to the answer. So again, we have minus 3.995 minus 3.995. So we have this to be minus 3.995. Okay, so now let's now test with our calculator which of these answer here correspond to this. So let's add that. Now for the first option, you will see 31 over 20 minus 4 ln 3 minus 4 ln 4 over 3. So let's impute that. Now here's a fraction. You press your fraction key. So we have 31 over 20. So we press the arrow down. We have 20. Then minus 4. So we have 4 ln 3. So we have ln. This is just your ln key. Then you press ln 3. Then you close the bracket. Then minus 4 ln 4 over 3. Minus 4 ln. So we have a fraction. So that means we press the fraction key. Then we have 4 over 3. Then after that, we can now press our equals to sign. So you can see, boom, we have minus 3.995. Okay, so we have this result. You can even just recall the memory of the calculator. If I press the arrow up, the calculator will bring out the last operation, the last few operations in which I performed on the calculator. So if I press the arrow up button, you can see I have minus 3.9951774. If I press arrow up again, you can see the value of my integral. You can see that means that option A is our correct answer. And if you practice enough with your calculator, you will actually know how to solve very fast with calculator. And if you are to do this with your hand, it will take you up closely approximately to maybe like 3 or 4 minutes with your hand. Okay, and you can even make mistake along the way. But using your calculator, it will take you less than, let's say, 1 minute. You are done. So you can see that learning how to use your calculator to solve integration problems is very, very important. All right, so let's move on to the next question. In this question, we are asked to evaluate the integral from minus 1 to 0 of x open bracket square root of x plus 1 dx. Okay, the very first thing we might want to do is for us to reset the memory of the calculator by pressing the shift button, then 9, then 3, then equals to, then press AC. Now that we are done with that, we can now press the definite integral key. Okay, so here we open our brackets and close the brackets. Then in the middle here, we input this function. So we have x open bracket square root of x plus 1 close bracket. So we have alphabet x open brackets. You can close the bracket because you want to put in the square root of x plus 1. So let's come back there, then press our square root key. Then after that, we can now press alphabet x plus 1 plus 1. Now that we are done with that, we can press the arrow down button, then now press our limit of integration, which is minus 1 for the lower limit, then press the up arrow button, then press 0. Okay, now that we are done with that, you can press our equals to button. Now it's evaluating that, then here we have this to be minus 0.26667. Okay, now if you should check your option, you cannot see anything like that. Now for us to know which of the one would give us this answer, I'm sure that it cannot be A, because it has to be minus. It's either C or D. Okay, so let me test for C and let me test for D. So I can press the AC button to clear the screen. Then if I press minus 4 over 15, so you can see that I have minus 0.2666, similar to what we had earlier. Okay, you can see that the answers are the same thing. So the correct option to this question is what? Option C. So let's move on to the next question. Here in this question, it says given that the integral from 0 to k of k x raised to power 2 e raised to power x cubed dx is equals to 2 over 3 open bracket e raised to power 8 minus 1. We are asked to find the value of k. Alright, for me to find the value of k, and I want to use my calculator to solve this, the very first thing I might want to do is for me to get the numeric value of this first. I want to get the numeric value of this. So I have this to be 2 over 3 open brackets, okay, e raised to power 8. So we can press the shift button for us to evaluate, activate this exponential function. And we have this to be 8. Then I'll press our arrow forward button, then press minus 1. Okay, then close the bracket. So let's get the numeric value of this. So we have this to be 1986.6. Let's just say 1987. So we have this to be 1987. We can write it somewhere. 1987. Okay, now that we've written this down, so now let's input our definite integral. So here we press the definite integral key. Nope, we open and close our brackets. Then after that, we can now input this integral here. So you can see that we have kx squared e raised to power x raised to power 3. Here, I'm not going to put in k. It is when I'm evaluating my definite integral, I can now manually put in my k. Alright, so let's have that. So we have this to be alphabet x squared. Then again, we have e raised to power x cubed. So first we have e raised to the power what? So we can now input our x cubed. So we have alphabet x. Then press this button. Then we can write 3. Then press the arrow forward. Press the arrow forward again. Then we can now press our down button to take us to the lower limit. So here we have this to be 0. And now we have this to be open. So because we have k here, so we cannot test the value of the options we are given. So let's test for 1. So if we input 1 here, what do we have? We have this to be 0.5727. Okay, that's not our answer. Okay, so let's put in 2. Let's see what we are going to have. So let's put 2 here, and up here let's put 2 here. You can just navigate. So let's put in 2 here. Okay, so let's press equals to sign. Boom. Okay, we have 1986.6386. So let's confirm. I think this should be the answer. 2 should be the answer. But again, let's confirm our answer. Again, you can just write this out somewhere to be sure that your answer is correct. So we have 2 over 3 open brackets e raised to the power of, so we have the shift e raised to the power of 8, then minus 1. So you can see that this corresponds to the former answer we had earlier. You can see that the answer corresponds. So that means the correct option here is what? Option B. Alright, so let's move on to the next example. Here they said given that a is a positive constant and the integral of 3x minus 1 all divided by x from a to 2a dx is equal to 6 plus ln 2. So we have to find the value of our a. Okay, now for us to do that, again we calculate the numeric value of this. So we have 6 plus ln 2. 6 plus ln 2. Since you know that most times your calculator will not give you the closed form of your answer. It will always give you the numeric form of your answer. Okay, because the calculator, the program, the way they program this calculator, anytime it is evaluating the definite integral, it will actually use one of the most powerful integration techniques, which will give you almost the same thing as your answer. Okay, now here we have this to be 5.30, so we can write this out somewhere, 5.30. Okay, now after that we can now put in our definite integral. So we have our definite integral, then we can use the keys here to navigate our, again, don't forget that you need to open and close your brackets just to be on the safest side. Then we put in this fraction here. We have 3 alphabet x minus 1, then press your arrow down, then we have this to be alphabet x. Now that we are done with that, we can now put in our, so I just know that this is 2 multiplied by, I can just do that simple arithmetic from my brain. So here we have 4, let's put in 4. Then here, if we should put this here, that means we have 2 times 4, that will be 8. So let's put in 8. So we have 11.30, which is now our answer. So let's go again. So we can just press the back button, then press the arrow, you can press the arrow down button just to navigate your way back to the lower limit and the upper limit. So here we have this to be 4. We are choosing option B now. That means we try 3. Then this will be what, 6. Boom. We have 8.30. That's now our answer. Let's try 2. So here we have this to be 2. Then here should be 4. Should be 4. Just do a little bit of editing. So we have 5.30. So that means this should be the correct answer. That means option C should be the correct answer, because by the time you find the numeric value of this, that's 1 over 2. All right, so we have this to be 5.30, which corresponds to this. So that means C is your correct answer. So let's move on to the next question. Again, I believe that we can all practice this, so you can just practice this by yourself. All right, so let's do that together. Press this key, then open and close the bracket just to be on the safest side. Now you see that the argument here is z, but here we have x. Like I said earlier, the default variable for your integration using your calculator is just x, so you have to see how you can manipulate that. So here we have the alphabet x, then we have exponential minus alphabet x. Okay, then we have the lower limit to be minus 1, then we have the upper limit to be 0. Boom, we have our answer, minus 1. That's all. So let's move on to the next question. In this question, we asked to evaluate the integral of x cos x dx from 0 to pi. Alright, now let me state out something clear here. Anytime you are evaluating trigonometric function, okay, anytime you are evaluating an integral in such a way that it contains the trigonometric function, the first thing you want to do is to make sure that you change this from degree to radian. Okay, again I repeat, this is the default one, is this D stands for degree. All right, so you must change it to what, your radian. And how do you do that? You do that by pressing the shift button, you press the mode button, then you can see default it's on 3, which is degree, but you have to change it to radian by pressing 4. So once you press 4, you see that the R has changed to what, the D has changed to what, R. Okay, that means you are now in the radian mode. That means any of your calculation will be in form of what, in form of radian. All right, now the reason why you have to put it in radian is because your pi here stands for pi radian. Okay, so let's just move on. Now press the integral button, then we input this, open and close a bracket, then we input this there. So that means we have the alphabet x, then we have cos alphabet x, then you close the bracket. Because there's one, you've already opened one bracket outside, that means you have to close the bracket. So if you open another bracket, that means you also have to close the bracket. So you have to be careful of how you open and close your brackets. That is why it's always advisable that anytime you open a bracket, you must close the bracket immediately. So let's move on. So we put the lower limit 0, then we put the upper limit to be pi. So let's press equals to, so we have this to be minus 2. So the answer should be minus 2. Okay, that's C. However, let's say my answer, let's say it's on radian mode. Sorry, let's say it's on degree mode. So let's say we are on degree. So if I press equals to sign, you can see that I'm having 4.9310. You'll be like, is my answer not? My answer is not part of the option, and you may choose option E. But however, once you are operating in the radian mode, anytime you are evaluating trigonometric integration, you must change it to what's your radian mode, and you can just do that by pressing your shift and mode, then press your 4, then press your equals to sign again. You see that it will give you minus 2, which is the correct answer. So the correct answer to this question is what? Is C. Now we have more complicated integral. Okay, now here we are asked to evaluate the integral from 0 to pi of sine cube t dt. Okay, for us to do that, make sure that since this one is a trigonometric integral, okay, an integral that contains a trigonometric function, you must change your this from d to r. Now let's say, suppose by the time you reset your calculator, it will come back to d, okay, but you must change it to r by pressing the shift button, then the mode button, then you press your 4. So you can see that I can no longer find my d, I can only see my r. Okay, so we are good to go. So we press the definite integral button, then we have open the bracket and close the bracket immediately. Then after that, we press our sign. So once you press your sign button, sign comes with an open, just one open parenthesis. That means by the time you press the argument containing the sign of that function, then that means you must close the bracket immediately. So let's press our argument, that's alphabet X, then I close the bracket immediately once I'm done with that. Now you can see that this is sine cube t. Okay, so you can see this arrow up button. So once I press this arrow up button, this is equivalent to pressing what? Sine cube t. Okay, it's just like you have sine x raised to power 3. This is still the same as what? Sine cube x. Okay, do you get that? So this is your calculator form, this is the normal math interpretation form. So I hope we get the idea. So let's just move on. Now that we have that, we can now press the arrow down button. We have 0, then we have the arrow up button, which is the pi. So we have shift and we press our pi button here. Then we have our equals to sign. So boom, we have 4 over 3 directly. So 4 over 3 without stressing ourselves. We have 4 over 3. So let's move on to the next question. In this question, it said by Wallis formula, evaluate this integral. Now let's say, suppose you don't even remember Wallis formula, but you have your calculator with you. Now let's do this with our calculator. Again, you press your, make sure that you are on radian mode, because this is sine, we have sine x. That's, we have like a trigonometric function containing our integrand. Again, you press your button, then open and close the brackets. Then after that, we press our sign button, sign alphabet X. Okay, so this is sign alphabet X, sign X raised to power 5. Okay, it's still the same thing as pressing your sign X, then press your arrow up button, then press your 5. Okay, now if I now put in my 0, that's lower limit, and my upper limit to be pi over 2. So for me to activate pi over 2, I need to press my fraction button. Then I can now press my shift pi, then over 2. Then now press my equals to button. You can see that I have my answer 8 over 15 without wasting time. Okay, that means that Wallis formula is actually also programmed in this calculator. So I have 8 over 15. However, make sure that you don't make mistake while you are imputing your function. Don't go and press x raised to power 5 thinking that you've pressed x raised to sine x raised to power 5. Okay, these are different ball game entirely. This is sine. The argument here is x raised to power 5. Okay, not x. But if I edit it and I have my sine x, then I can now press this key, which I can now press my 5 button, which will now give me my results. Okay, so make sure that you don't make that mistake while you are inputting your arguments. Oh, so we have this to be 8/5. So this is our correct answer. So let's move on to the next question. Here again, they said by Wallis formula, evaluate cos x raised to power 5 multiplied by sine square x from 0 to pi over 2. Again, we press our button. Okay, we press the integral sign button or the definite integral button. Then here we open and close a bracket. Then after that, we press cos x, because we want to achieve cos x raised to power 5. So first thing is how we press our cos x first, then we close the brackets, then we put 5, take it to raise to power 5 using this button here. Then here we press our arrow forward, because if we don't press our arrow forward and we continue pressing sign, that means we are saying that we are saying cos x raised to power 5 raised to the power of sine 5 blah blah blah, but we are not doing that. So let's delete that, then press our arrow forward. Then now just a couple of practice, you would get the whole idea. So press your sign button, then press your alphabet x, close the bracket, then press your square button. So we are not done with that. We need to put in our lower limit, which is 0, and the upper limit, which is pi over 2. So we need to press the fraction button, then we have our pi over 2. Boom, 8/5, 8/105, 8/105. So without even picking down your pen, you already get your answer. So you just need to practice it with, you just need to practice your calculator with more examples on integration. This is just like few examples, but in your leisure time, make sure you just practice more examples and you get the whole concept. So let's move on to the next question. So here we want to evaluate the integral from 0 to 1 of dx over square root of 1 minus x squared. Alright, so here let's put in our value of our integral. So here we have this to be, we open and close the brackets, then we have this to be 1 divided by square root of 1 minus alphabet x squared. Then we put in our lower limit, then we put in our upper limit. Now let's see whether this will give us the answer. So I'm having a math error. Let's go back. So what's wrong? I don't think there's anything wrong here, but now I think I know the reason why it is giving us math error. We're having math error because, like I said earlier, this calculator here, your calculator is actually using a particular type of numerical integration, alright, in which it will have to substitute the upper limit and lower limits. Now you notice here that if I substitute my upper limit to be 1 here, what do you notice? I'm going to have 1 over 0, which is undefined, right? But however, if I put in 0, I'm going to have 1, so I don't have problem with that. But if I put in 1 inside this function, I'm going to have 1 over the square root of 1 minus 1, which is going to give me undefined. So that is why it is giving us math error. Okay, now for you to know what I'm saying is right, let me put in any value that's less than 1 and see what it will give me. So let me put 0.5. Let me change the 1 to be 0.5. 0.5. You see that it's giving me pi over 6. Not only that, you can even try it for 0.9. 0.9. You can see that it's giving me my value. So that means that anytime you put 1 there, because I know that 1, by the time I substitute 1 inside this function, I will have undefined. So my calculator may not work. So that means using your calculator, you may not necessarily use your calculator for all the definite integral you see in your exam. You may just have to, take all those things I said into consideration. You cannot use your calculator to evaluate any type of function in which by the time you substitute the upper limit and lower limit there, in a way you have undefined. So you cannot use your calculator to do that. Okay, so let's move on to the next next question. You can actually use hand to solve this, and by the time you use your hand to solve this, here we have this to be arc sine of what? Of x, and here we have the lower limit to be 0 and we have the upper limit to be 1, and arc sine 1 would give us what? Would give us pi over 2. Sine 90 is 1, so sine pi over 2 will give us 1, then minus the lower limit. Arc sine of 0 is still give us 0, so that means the answer to this question is what? Pi over 2. All right, so let's move on to our next question. In this question, we have to evaluate sec x open bracket sec x plus tan x dx from minus pi over 4 to 0. Okay, now for us to do this, first make sure that this radian mode is already activated. Okay, now after that we can now press our definite integral button. Okay, open and close the brackets as usual. Then here, now you can see that in your calculator you don't have anything like sec, you don't have anything like cosec, but however you remember that the inverse of cos is what? Sec. So that means I have this to be 1 over cos x, 1 over cos x, so we have this to be cos x, cos alphabet x. Okay, then after that we can now open the brackets, then close it again, then come to this middle because we want to impute sec x plus tan x. So what our sec x is what? 1 over cos x, so we have cos alphabet x, close the bracket, then plus, just for you to have your plus, just press your arrow forward button, then you can now press your plus after that, because if I press my plus here, you can see that means I still have some other things I want to write, so I can just delete that, then put my plus here, then tan x, so we have tan alphabet x, then close our brackets. Okay, so let's see what we are going to have. So we've not imputed the lower limit and the upper limit. So at the lower limit here we have this to be what? Minus pi over 4, so we have shift pi over 4, so we press our arrow button here, then just navigate to the upper limit using this navigation key here. So here at the numerator here, sorry, at the upper limit here we have this to be 0. So once we are done with that, so let's evaluate this, let's see what we are going to have. So we have this to be 0.5857, 0.5857. So let's see 2 minus root 2. 2 minus root 2 is what? 0.5857, which corresponds to this answer. So that means the correct answer to this question is what? Option A. Alright, so let's move on to the last question for today. In this question, they said given that the integral of 1 minus pi sine kx all dx, taking the lower limit to be pi over 4k, then taking the upper limit to be pi over 3k is equals to pi open bracket 7 minus 6 root 2. So we have to find the value of k. Now for me to do this, my very first job is for me to calculate the numeric value of this. So let's do that. So we have pi open bracket 7 minus 6 root 2. 6 root 2. Okay. So we have this to be minus 4.666. Minus 4.666. Okay, so now that I'm done with that, so I can now impute my integral. So we have this to be open and close your brackets. Then here we have this to be 1 minus pi, then sine. Then here we have kx, but I can just put in x, only alphabet x. Then later I can do my editing, then I can put in the value of my k. Here we have this to be pi over 4k, so I can just leave that to be 4. Then here I will have this to be pi over 3k. Okay, so here we have k to be, here we have k to be either 1 over 4, 1 over 8, 1 over 10, or 1 over 12. Alright, now you know that if my k is 1 over 4. That means that if I substitute k here to be 1 over 4, that means I'm going to have this to be pi. Then here will be 4 over 3 pi, 4 pi over 3. I hope you get the idea. This is what I'm saying. Here we have this to be pi over 4k, and here we have this to be pi over 3k. If my k is 1 over 4, this upper limit here, I'm going to have the upper limit here to be 4 pi over 3, and the lower limit here to be just ordinary pi, because my k is 1 over 4. Just a little bit of substitution. This is what I'm saying. If you have this to be 1 over 4, you can see that this will cancel out this, and I'll have this to be pi. And if this is 3 pi, if this is pi over 3k, so if my k is 1 over 4, this is still the same thing as 4 pi over 3. So I hope we all get the idea. Alright, so let's move on. So here we have this to be 4 pi over 3. Then here we have this to be ordinary. We have this to be ordinary pi. You can just leave it to be pi over 1. Alright. So then here we come to this. We come to this place, like in the front of our x. Then here we have this to be, we have our k to be pi over 4. So we can just press this fraction here. Then here, so let's press our delete button. That's not what I wanted rather. So I can just have this to be pi. Then if I press this fraction button, so I can have my fraction button. Then here we have this to be x over 4, since I know that my k is just 1 over 4. So if I press my equals to sign, I hope we get the idea. So if I press my equals to sign, I have minus 1.55555. So I'm sure that the answer is not what? It's not 1. Okay, so let me change it to, let me change my k to what? To be 1 over 8. So if I change my k to be 1 over 8, so here the upper one here will be 8 over 3. Okay, that will be 8 over 3. 8 over 3. Then the lower limit here would be pi over 2. Okay, pi over 2. Then I'm going to have this to be x over 8. Okay, because my k is pi over 8, so I'm going to have that to be x over 8. So this should be over 8. So let's see what we're going to have. So I have this to be minus 5.2766. Still not yet the answer. So let me change my k to be, let me change my k to be 1 over 10. So if this is 1 over 10, I'm going to have this to be 10 pi over 3. Then this, I'm going to have this to be, I have 10 pi over 4. So we have this to be 10 pi over 4 over 4. That should be 5 pi, but let's just leave that like that. Then here we have this to be x over 10. Okay, so we have this to be minus 3.88. Still not the answer. So let's just try the last last option, which is when k is 1 over 12. So that means we have this to be 12 pi over 3. Then here we have this to be 12 pi over 4. 12 pi over 4. And here we have this to be, you can just navigate this to be x over 12. And now we have our answer, which is minus 4. So you can see that when k is equals to 1 over 12, we have our result. So that means our correct option here is what's option D.
Well, we've come to the end of today's tutorial questions. If you have any question, any comment, any suggestion you want us to know, you can put them in the comment section box below,
And also don't forget to click on the like button so that more people can get to know about this. And together let us defeat this academic failure. Thank you.